Morning. Last week we were able to go through the basics of pandas, and we looked at pandas series and pandas data frame, and we recall that we said the pandas series is just a one-dimensional labeled array. So it means it contains labels, which is why it is different from a NumPy array or a Python list. And it is implemented in C, so which makes it faster than a Python list. And we also looked at a pandas data frame, and we saw that there are two-dimensional data structure that can contain data of any type, so similar to our Excel spreadsheet or a SQL table, while a pandas series is just like a column in an Excel spreadsheet. So now today, let's just quickly look at some other things we can do on our data with pandas. So let's look at missing data. Let's first import NumPy and pandas. And now I want to create a data frame with missing values. I can just simply do this with NumPy using np.nan. So now this means anywhere there's np.nan, it just fixes null values there. So it means if I run this now and I call df, I'll see I have a null value here, a null value, and another null value here. So now if we have just few null values, we can just decide, okay, we want to drop the null values, and we can do this with the drop na method. So we just use df.drop na, close parentheses. Let's use shift tab to see the arguments we can pass in. We can see by default axis is equal to 0. We have trash. So now by default axis is equal to 0, which means it is done along the row. So which we can see here. If we run this now, we'd see every row that has a null value is automatically removed. It leaves just this first row because it has no null value. Now we can also set axis is equal to 1 if we want to perform this operation along the column. So if we do this, we'd see it drops every column with a null value, and it leaves just column C because it has no null value. We can also set an extra argument, trash. Now let's see what trash is. So now we can see it is an integer value. It will require that many non-NA values. Now what this means is if I set trash is equal to 2, for the column or the row not to be dropped, it will require 2 non-null values. So if I said trash, for example, is equal to 1, it means it will look at the rows now, since axis by default is 0, and look at any row that has at least one non-null value. So it will just automatically leave it, it won't drop it. Setting this now, we see it leaves all the rows because this one has 3 non-null values. It is greater than 1, 2 non-null values. This one has just 1 non-null value, which is 3, which is why it doesn't drop it. If we set trash is equal to 2, anyone that doesn't have 2 or more non-null values is going to be dropped. Now we'd see the third row was dropped because it has just 1 non-null value and it doesn't have up to 2, and we said the trash has 2. So now at the same time, we can also decide to fill these missing values with whatever we want to fill it with. Now a lot of times it's there are different ways to know how to fill in missing values, which I believe we'll address later on when we are looking at building models, pre-processing data and the likes. So but now, since it's just for us to have the basics of what we can do with pandas, we use the fill now method to fill values. So let's imagine we want to fill missing values. Now using df.fill now fills the missing values for the entire data frame. So we selected value as fill value, a string. So it replaces it with this string fill value. Every null position is replaced with this. Now if we want to fill in for just the first column, which is column A, we just use df. We specify that it is this first column, which is why we can see in square brackets A is indicated, and then dot fill na. We can see the arguments we can pass in place is equal to false. We already know what in place means, so we can now specify the value. So it means once by using min now, which means it's going to fill in every null value in this column A with the mean of the values in column A. Now don't forget, in column A we have just 2 numbers, 1 and 2. So the mean of 1 and 2 is 1.5. So it fills in this null value as 1, it replaces it with 1.5. Now we can also do different things with pandas. Let's look at another powerful thing we can do, which is the group by. Now, with the group by methods, we can group rows of data and call an aggregate function. What I mean is this: imagine we, let's imagine you are an employee in an e-commerce company, and you have so many customers. Now, these customers make repeated transactions. So a customer can make purchases from your company. Let's assume Jumia. Let's assume 1,000 times in just 1 month. So now, what you want to do is you want to see the customer that spent the highest amount. Now, don't forget, if you are recording, or if okay, let me still go with that example. If you are recording the values now as, okay, let's imagine the name of the first customer now is now let's imagine these are not company names but human names. The first one is Google, the second customer name is Microsoft, the third customer's name is Facebook. Now, if this first customer, Google, purchased something of the highest purchase he made was 150,000. His next highest purchase was 120,000, and then Microsoft made the third highest purchase, 100,000. If you want to select just three customers, let's assume you have an endless list, like so many rows of data, and want to select just the top three customers. Now, using the value alone, it means, don't forget, the person that made the first and the second highest, largest amount, that spent the top two largest amounts, was the same person. This same Mr. Google here he spent 150,000. At the same time, he spent 120,000, and then Mr. Microsoft spent 100,000. So, which means we would be giving a bonus gift to the same person twice. So, what if we could just group by, and then we are not going to have repeated names? We'll just get for each name now, and then we'll pass the value, anything we want to get. It might be quite complicated. Let's evaluate what I'm trying to say. Now, let's imagine we want to group by company now, in this example now. So we just use df.group by company. So we use the group by method. We pass in the column we want to group by. Now we see the output is just telling us that it has created an object at this position in memory at 0x blah blah blah. And then now let's imagine in this example now, in the former example I said, we want to find the maximum value for each company. So now let's imagine we want to find the highest amount each individual made. What we're just going to use is, after we have grouped by, so in this case, the companies now, we just use dot max, we use this, and it gives us for each company the maximum amount. So let's assume we're interested in the sales column. Facebook has made the sales value, the maximum sales value, 350. Google made 200. Microsoft made 340. So instead of seeing, so now you can see we just have Microsoft, it has grouped it by, Microsoft is now a collective company. Even if Microsoft is existing in 10,000 rows, all the rows will be combined together. Since we are calling max, so since we are using max as the aggregate function, it's just going to give us just the maximum value, and we are not interested in any other value. The same way we can perform other functions on it. We can get the mean, and now this is just doing it in one line. Don't forget, here we set df.group by company to a variable named by comp. So if we don't want to do this, if we want to do it in one line, we can just use this same line and then use .min on it. We still get the same value. And we can also get standard deviation. We can get anything we need, basically. We can get the minimum value for each company too. And we can also count. So the sales, so how many rows do we have for Google, Facebook, and Microsoft? So it tells us, okay, for the person's column, we have just 2. For sales, we have 2. Now, we'll notice that when we used mean, we didn't get any value for the person's column. When we use standard deviation and the mean, this is because the person's column is a non-numerical column and we can't evaluate mean or standard deviation for that particular column. Now, we can also use .describe, which we looked at last week. It gives us all important descriptive statistical summary of the data, and then we can transpose it. So we know what transpose means. So just changes the way it looks for us. And then we'll try to move very fast. Let's go to another powerful thing we can do with pandas. Now we can decide we want to combine data frames together. We can do this by either merging, joining, or concatenating. Now we'll look at each one of them and see how we can use it. What pandas? Let's create data frames df1, df2, df3, so we'll be able to look at what we are trying to do. Now let's concatenate these three data frames. Now what concatenation does is it just combines the data frames together. It's typically like literally glues them together, and it does it along the axis we are concatenating on. So which means if this is what we are doing now, if we to concatenate now, we just use the concat method. So pd.concat, and then we pass in, use shift tab, we can see the arguments we can pass in, and then we see that we want to concatenate df1, df2, df3. Now by default, using shift tab, by default, you see it is done along the row, axis is equal to 0. So which means it just combines each one. So it takes the first data frame df1, it adds the second one to the bottom, it adds the third one to the bottom. So we see it now gives us a longer data frame. Now, what if we want to do it along the columns? We just specify axis is equal to 1, and doing that, we'll see it is no longer doing it. Now, we still have a longer data frame, but now filled with many null values. Now, what this does is it just combines the columns together. So it does it side by side instead of on top of each other. So you have the first 4 columns, the columns of the first data frame, adds the second data frame, adds the third data frame. Now we'll notice for the second data frame, it started at 4. That was the first row was, now this is what I'm trying to say. Here we'll see it started at 4. This one started at 8. So at 4, between 4 to 7 for this second one, this first data frame add no value, the second one adds no value. So it just fills in null values for them. It goes to the third one when it joins it again, column by column. And then we see at 8 to 11, these ones have no values. So it just fills in null values, which is why we can see so many null values here. Now, what if we do not want to concatenate, which means we don't want to repeat everything we have? Concatenation just means we are joining this, we are gluing them together. Even if we have some columns that are present in the second one, it doesn't matter. It will still be repeated in the new data frame we're trying to create. So now we can use, let's create random data frames again. Now here I changed this to K14 on purpose. In the notebook we have it is K1. Why I'm changing it to K14 is because if it is K1, we would not really see the effect of what I'm trying to do next. So we can try to change K1 to K14 in the left data frame, and so we'll be on the same track. Now, if I want to merge, just like we merge with SQL, we just use the merge method. So pd.merge. So now this is what we are trying to do. Don't forget this, we're using the merge function. So because we want to merge these two together, the two data frames, left and the right data frame. Now look at the arguments we can pass in, left, right. So the two data frames, how we want to merge it, on which column we want to merge it. Now let's imagine we say we want to merge. There are different ways we can merge. We can merge inner, outer, left or right. Inner merge just means now it will pick the keys because we are merging on the key column. So it is merging on the key column. It will look at the key column, where they have similar columns, where they have similar values in the key column. So like the intersection is where it will be merged on. This is what I'm trying to say. Now don't forget what we had was we had 4 keys for the two data, for the left and the right data frames. But now we can see that when we use an inner merge, we have just 3. Now, if we left it as K1 instead of K14, which I changed it to, we'll not be able to understand the changes that are being made because we'll be getting the same output for everyone. So now what this inner mesh just did is, now look at the data frame we defined. We see the common key values are K0, K2, K3. But K1 is here, but is not here. K14 is here and not here. So it removes it. It just uses what is common to them. And it merges on the key column like that. Now, what if we wanted to use a left merge? And what this does is we preserve the left data frame. So now the key values for the left data frame, K0, K14, K2, K3. K1 is not here now because K1 is not in the left data frame. And then it merges along this key with these key values. And don't forget that K14, see this for this second data frame with the column C and column D have no values. So it replaces it with null values. If we change it to right, the K1 will appear because it will leave everything in the right data frame. So K1 appears if using null values for the left data frame. So we can try different ones. We can try outer merge and see what we get. So now let's show, okay, to show a more complicated example. Now we have two keys now. We have key, we named it key. We have two columns with keys. So key 1, key 2, key 1, key 2. Now, if we want to merge, don't forget by default the merging type is an inner merge. So if we want to merge on these two keys now, key 1 and key 2. So now what happens is the same way again, inner merge, it looks for the common values along these columns. So for key 1, we can see K0, K1, K1, K2. So what is common between these two? We have K0, K1, and then there's a K2 here again. So it just looks for common values the same way we have done. So but now we are merging on two different columns. So it uses these two columns that we are merging on. So it performs an inner merge, not with one column now, but with these two, and then it gives us a resultant data frame. So key 2, the same thing again. So it means if we change the how here, we can try it to a left merge. We'll see we'll get a different value. So now the same, okay, they tried it with an outer. Now here we have an outer merge. So with an outer merge, an outer merge combines the two data frames together. So it doesn't look for what is common, or it doesn't preserve just so what is in both data frames, we would see it in the two of them. So it brings everything out and it merges with everything. So okay, we have the right here, right merge. It preserves all the keys, key 1 and key 2, since we are merging not just on key 1 but on key 1 and key 2. So it preserves key 1 and key 2 for the right data frame. Using left does exactly the same thing, but it does it for the left data frame. It preserves key 1 and key 2 values for the left data frames. And for the values where on these keys where we have no value for the second data frame, it's using null values there. And at the same time, we can also join. So we can combine columns with different indexes into a single data frame. Now, this is what I mean. Now, don't forget we have this, the index of this is different from the index of this. This is K0, K1, K2. This is K0, K2, K3. Now, if we want to join the left and the right data frames together, we just use the join method. So use Shift Tab to see arguments we can pass.